So we're looking at 7th grade lesson 3.3, and we're going to be talking about the distributive property. Now we actually have two goals here. I can simplify expressions, and I can use the distributive property to simplify expressions. So we're going to look at how we use the distributive property in problems, and then we are also going to look at how to simplify problems if we're given what the variable equals. So we have one vocabulary term. This isn't really the definition, but it's how it's used. So the distributive property is used to simplify expressions involving multiplication of terms inside parentheses that cannot be combined. And the number on the outside of the parentheses is multiplied by everything on the inside. So to give you an example, if you have the quantity 2 times the quantity x plus 4, we cannot solve x plus 4 because those are not like terms. They can't be combined. And so if that were given to you in a problem, you couldn't go any further. Except for we know the distributive property, I can take 2 times x and 2 times 4, and it's going to give me the same thing. And so that's why we use the distributive property, and that's why we're talking about it now. So here are some examples. We have the first one, -5 times the quantity v plus 4. So, oh my goodness. Don't know what's happening with my computer right now. Okay. Well, I'm just going to delete this. So if I take -5 times v and then do -5 times 4, -5 times v gives me -5v. -5 times 4 is -20. So I end up with the answer -5v plus -20. Now over here for the second one, I have 2x times the quantity x minus 2, and then that's being added to 3x squared plus 3x plus -12. Oh my goodness. So, I take the distributive property and I do 2x times x, the first term, then 2x times minus 2x times 2. Okay, so the minus was inside the parentheses, it carries down. Everything else just carries down exactly the same. So you notice 3x squared plus 3x minus 12, 3x squared plus 3x minus 12. Next thing I'm going to do is simplify my expression. So 2x times x is 2x squared minus 2x times 2, that gives me 4x because 2 times 2 is 4. The x just comes along for the ride, and then again everything else carries down. Now I'm going to rearrange the problem so like terms are together. And just like whenever we were doing prime factorization and I had to go from least to greatest, here there is a special order. And so you notice I put 2x squared plus 3x squared first. That's not just because 2x squared was the first value in the line above it. It's because when you are listing numbers that have different values, you want to put the higher exponents first. So x squared compared to x compared to no exponent, the x squared gets priority. It gets listed first. So what I did was I rearranged everything. And then notice it was minus 4x. The minus 4x carried over. So the sign in front of it carries down. Now that I have my like terms together, I can combine. So I get 2x squared plus 3x squared is 5x squared. -4x plus 3x, because remember this minus 4x can also be read as -4x. That's -1x, and then minus 12 stays minus 12. Didn't do anything with that the entire time. Now we can apply this to perimeter and area. Now perimeter of a figure is 2 times the length plus 2 times the width. I wrote it with the parentheses just so you can see why I'm putting it here. So I'm going to take 2 times the length plus the width. You could have also done side plus side plus side plus side. All of those are the same. So, I have 2 times length plus width. So next I'm going to just replace my values. So 2 times the quantity 5x minus 4 plus 5x. Now I'm going to, don't know what's going on with my computer today. I'm going to combine the 5x's. Now I didn't rewrite it with them together, but I could have. I just went ahead and did 5x plus 5x and then the minus 4. I still haven't done anything with the 2. I'm about to though. So 2 times 10x minus, that minus sign carries down, 2 times 4. 2 times 10x is 20x minus 2 times 4 is 8. So the perimeter is equal to 20x minus 8. Now the area is length times width. So I'm going to take the length, which is 5x, times the width, 5x minus 4. So again, distribute it. So 5x times 5x minus 5x times 4. 5x times 5x is 25x squared. 5x times 4 is 20x, so 25x squared minus 20x. We're also going to use our triangles. Now for a triangle, the perimeter is side plus side plus side. Now I did these little subscripts, side 1 plus side 2 side plus side 3. That's what this means. It's just to show you the difference between the three sides. So I'm just going to add together everything. Now whenever I wrote it out, I put everything in parentheses so you can see, goodness, the different sides. So x minus 7, x plus 1. The order doesn't matter. Then I put like terms together. So I pulled out all of my x's. And all of the x's were being added. So this is the same as multiplying by 1, so I can just take out the parentheses. So x minus 7, x, I pulled those out together. Minus 7, that's important. And then the plus 1. And then I combine those. X plus x is 3x. Negative 7 plus 1, it's negative 6. So the perimeter is equal to 3x minus 6. Now area, we do 1/2 times the length times the width. Or you can also do length times width divided by 2. Now the reason for this is, we imagine this. This is a right triangle. If we imagine this were a rectangle, I would find length times the width for the perimeter. Now, because it's not a rectangle, it's only half the size. It was cut in half. So it's 1/2 the length times the width. I could have also written it 1/2 base times height. And that's where you're going to see it more often. Base is the length here, width, height is here, the width. Same thing. I used 0.5 instead of 1/2 because I couldn't enter in 1/2 as a fraction in the program, so I had to use its decimal equivalency. Oh my goodness. So I go through 1/2 times x minus 7. All of this is being multiplied. 1/2 times x is 0.5x, and then that's still going to be multiplied by x minus 7. So I'm taking my multiplication one step at a time, because now I have a distributive property problem. I'm going to multiply 1/2 x times x and 1/2 x times negative 7. And that's why I kept it in the parentheses, because this is one entire term. The height here is the value x minus 7. So 1/2 times x, 1/2 x times x minus 1/2 x times 7. 1/2 x times x is 0.5x squared, because x times x is x squared, and 0.5x times 7 is going to be 3.5x. So 0.5x squared minus 3.5x. Now my last problem that we're going to look at is just evaluating if we know what the variable equals. So here we're going to evaluate if x is equal to negative 2. So I have the problem 7x minus 8 minus 2x. Now I go through, and every time I see the letter x, I replace it with negative 2. So 7 times x becomes 7 times negative 2, minus 8, minus 2 times, again, x gets replaced with negative 2. Now, follow my order of operations, multiply. So 7 times negative 2 is negative 14, minus 8, minus, and then 2 times negative 2 is negative 4. And then I'm going to add and subtract one piece at a time because I want to make sure I don't mess up my negatives. So negative 14 minus 8, that's negative 22, minus negative 4. Now minus the negative, remember, stay, switch, switch. This becomes plus, this becomes positive 4. So negative 22 plus positive 4, that's negative 18. Now, my second problem, I have v and x. So 9v plus 2x minus 7x minus 2v. So I go through, and every time I see the variable x, I replace it with negative 2. So 9v just stays the same, plus 2, I replace the x with negative 2, minus 7, again replace the x with negative 2, minus 2v. Now I multiply. So 2 times negative 2 is negative 4. 7 times negative 2 is negative 14. So 9v plus negative 4 minus, carries, negative 14 minus 2v. Now I'm going to rearrange it so my like terms are together. And again, I'm going to list the variables first. So 9v, and then it's minus 2v, because remember that the sign travels with the number. So 9v minus 2v plus negative 4 minus negative 14. 9v minus 2v is 7v. Negative 4 minus negative 14 becomes plus positive 14. Negative 4 plus positive 14 is positive 10, so 7v plus 10. So we're going to be working mostly with the distributive property tomorrow, but I did want to introduce this last value, this last process, just so that you're aware of it. But like I said, tomorrow we're mainly going to be working with the distributive property. If you have any questions, I will answer them then.